In this video, we will talk only about some terms that we learned in Chapter A about energy metabolism. Chapter A starts with information about what metabolism is, and it's really the summary of all chemical reactions in the body. Could be reactions that give us energy, which were the focus of Chapter A. Could be reactions just to synthesize new molecules. Could be reactions to remove toxic substances from our body. So the summary of all chemical reactions in our body is what we call energy, what we call metabolisms. Part of these reactions provide us energy, means we get calories, and this is what we call energy metabolisms. And this was the topic of Chapter A. Based on what happened in a metabolic reaction in general, we classify metabolic reactions into two main groups, anabolisms and catabolisms. Anabolic reactions are reactions in which we start, for example, with something, we synthesize a larger molecule. So we start with something simple, or at least simpler than the end molecule, and then we convert this into something larger. And I call your attention that this is just a simplified view of or a way to show you this information, okay? One example is glucose. When we convert glucose, when we have high glucose levels in our blood and we try to remove this from our system, and if we don't need it for energy, we store this in the form of glycogen. This is called glycogenesis, and this is an anabolic pathway. In this type of reactions, in general, we consume energy. So we need to build a new molecule, and this requires some energy. Catabolic reaction, in contrast, we start with something larger, and then we break down these molecules. We break down bonds in this molecule to obtain something simple. Okay, so for example, we start with glycogen in case we are low in glucose units, and then we obtain glucose. A polysaccharide, a larger molecule, is used to obtain glucose units by breaking bonds in glycogen. This type of reactions release energy, or this type of reactions releases energy and bonds are broken. And then in this type of reactions, bonds are formed. And then we, another example of a catabolic reactions is, for example, when we have glucose or we have amino acids, and then we break down bonds in these molecules to obtain ATP, or, well, CO2, for example, which is a simpler molecule. Okay, this is a type of reactions we see in the pathways we learn in class. In the pathways we learn in class, and then in this type of reactions, energy is released in the form of ATP. And sorry for the mistyping here. Okay. So again, anabolic reactions, we create something larger, we require energy to do it, therefore we require energy to do it, and bonds are formed. In catabolic reactions, energy is released and bonds are broken. So most of the pathways we learn in class when dealing with energy metabolism are catabolic reactions. Okay, and these are three of the terms we learn in class. We also, depending on the use of oxygen or not, we classify pathways as anaerobic when they do not require oxygen, or aerobic when they do use oxygen. And in the morning, I used to help you memorize this. This is N for no oxygen. Example of anaerobic pathways that we learn in class is glycolysis. Again, I will talk about this in the second video, whereas the other topics we covered in class, like TCA cycle, etc., they are aerobic. And then at the end of the chapter, we also talk about absorptive versus post-absorptive states. And this is more related to what happens to your body depending on your metabolic conditions. Just right after a meal, so 4 hours or around 4 hours following a meal, we are in what we call absorptive state. So we just absorb all nutrients. We are high in these nutrients, high in glucose, high in amino acids, etc. So what happened in this state is mainly, not only, but mainly anabolic reactions. It means we will store energy. For example, glucose is converted into glycogen. Again, glycogenesis. So mainly anabolic reactions, whereas many hours or when you are in fasting, after 4 hours or more, then you still are in need of energy and you don't have the nutrients to get this energy. So you need to use your stores. In this part, we use our stores. And what happened here is mainly that we will break down this store. So mainly catabolic reactions, like for example, glycogen is break down to glucose, which is called glycogenolysis. I hope this will help you to understand this topic, and I encourage you to have or to look the second video about catabolic reactions and